going to start this unit by looking at simplifying and expanding radicals. We're going to convert 3 root 5 into an entire radical. So before we go any further, let's go over what an entire radical is. So an entire radical means you're multiplying together a radical by 1. So your answer will be in the form 1 times the root of x, and very often we just write that as root of x, where x is some sort of value, because 1 times a number doesn't change what that number is. So we have 3 root of 5. We want to change it into the entire radical. So what our goal is to get rid of that number 3 that's in front. And when I say get rid of it, I mean move it under the radical. So we have 3 times the root of 5. Now, if there's no degree written in front of your radical, we assume that it's a 2. And what we're going to do is we're going to take that number 3, and because it's degree 2, we're going to put 2 copies of it under the radical sign and multiply it by the number 5. So 5 times 3 times 3 gives us 45. So our answer to this would be the square root of 45. Now, if you're doing a square root, writing the 2 there is optional. I just want to take a moment and just talk about some terminology very quickly. This value is called the degree, and the value that's under the radical symbol is called the radicand. So the square root of 45 has a radicand of 45, and it has a degree of 2. Next problem. So it may look slightly more complex, but the process is the same. So we want to convert 2k to the power of 4 times the cube root of 5k into an entire radical. So to convert this into an entire radical, we're going to take a look at what the degree is. In this case, we have a degree of 3. So this 2k to the power of 4, we're going to put 3 copies of it under our radical sign. So we end up with something like this. So now this is in the form of an entire radical. We're going to have to simplify it a bit. So let's take our integer values and multiply them together. So 5 times 2 is 10, times 2 is 20, times 2 is 40. So that will be the cube root of 40. And let's take our powers of k. So we have k to the power of 4 3 times. That gives us k to the power of 12. And then we have k to the power of 1. So that's going to give us k to the power of 13. So we're multiplying these values of k together. The base is the same, so we're just going to add all of these exponents. So our final answer is the cube root of 40k to the power of 13. So that's converting it into an entire radical. Question 3. Now we have something that's in the form of an entire radical. We're going to convert it into a mixed radical. So we have root of 75. We want to make this a mixed radical. So it's going to be in this sort of form, where there's some value in front of the radical that is not equal to 1. Okay. So my preferred method for doing this is by using prime factorization. We take the number 75, and we want to break it down into all of its prime factors. That is, the prime numbers that will multiply together to give us 75. So what are 2 values that multiply to give 75? Well, we could say 3 times 25. And now let's see if any of these break down any further. 3 is already a prime number, so we can't factor that into any other prime numbers that multiply together. 25 is not a prime number, though. What are 2 numbers that multiply together to give you 25? Well, it would be 5 times 5. None of these break down any further. Those are all prime numbers. So we have 3 times 5 times 5 as the prime factorization of 75. And at this point in time, especially if it's a larger one, you might want to check just quickly in a calculator. 3 times 5 times 5. Verify that that gives you 75, and it does. Okay, so the root of 75 is equal to the root of 3 times 5 times 5, and this is assumed to be a square root. So what we're looking for are pairs of the same prime number that are under this radical symbol. So we have a pair of 5s, so we're going to cross those out and write a 5 in front of our radical symbol. We have a 3 that's left over that is unpaired, so we're going to leave it under the radical symbol. So what is our answer? It would be 5 times the root of 3. So that would be the mixed radical in simplest form. I'd just like to note that if you were breaking 75 up, perhaps instead of 3 times 25, maybe you would have said 15 times 5, which would also be valid. And 15 times 5, well, 15 would break up into 5 times 3. 5 would break up into 5. So note that it doesn't matter what pairs that you break it into along the way. You will end up with the same prime numbers in the end due to this prime factorization. Here's a larger number to work with, 2,600, and we want to convert that to a mixed radical in simplest form. Let's do our prime factorization again. Okay, so it's clear to me that 26 times 100 will work here, so that's what I'm going to start with. How could I break 26 down into two factors? Well, this is the same thing as 13 times 2. How could I break 100 down into two factors? This is the same thing as 10 times 10. Since we have a pair here, we could technically stop and answer the question with it. But let me just go further. 10 is 5 times 2. And our other 10 is also 5 times 2. So here's our prime factorization of 2600. If you wanted to check to make sure that you got the correct answer, well, just work this problem out in your calculator quickly. And if it works out to 2600, you know you're good and you did your prime factorization all right. So we have 2600. That is equal to the root of 13 times 2 times 5 times 2 times 5 times 2. And again, we have a square root here, so we're looking for pairs under the radical sign. Well, we have a pair of 2's, so we're going to write this in front of our radical. We have a pair of 5's, so we can take that pair out. We don't have a number to pair the 13 with. We no longer have something to pair this 2 with because we've already taken a pair of 2's out. So we have taken out as many pairs as we possibly can. So when we get to our answer here, we're going to group together these terms that were factored out. 2 times 5 gives us 10 times the square root of, and we're going to multiply those two values that are still under the radical sign. So 13 times 2 is 26. So this would be equal to 10 times the root of 26. Now there are other methods that you can use for doing this, but I just find that the prime factorization is a method that will never lead you astray, and this concept will actually be helpful in other types of mathematical problems that you might encounter in high school and in university as well. Alright, so here's a problem involving variables this time. Convert the fifth root of m to the power of 9 to a mixed radical in simplest form. Now, m to the power of 9 is m multiplied by m 9 times. So I have 9 copies of m under my radical symbol. I want the fifth root. So that means I need 5 copies of m taken out. So 1, 2, 3, 4, 5. And looking at what's left, we have 1, 2, 3, 4. So we can't take another m out because there are not 5 copies of it. So what is our answer? This is m times the fifth root of m to the power of 4. Now, you don't have to write out all of these m's every time that you do this problem. Another way that you might have looked at it is this is the fifth root of m to the power of 5 times m to the power of 4. And why I might break it up in this way is because m to the power of 5, given that I have a degree of 5, will mean that 1m comes out. Either solution will lead you to the correct place, but I just want to show you kind of conceptually what this fifth root would mean. It would mean that 5 factors of something has to be present under the radical symbol before you can take one copy of it out. Alright, our final problem. So we're going to take these 4 expressions and order them from least to greatest without the use of a calculator. Okay, well, just by observing, that's not necessarily going to be simple to do unless we convert them into similar forms. So let's convert each one of these into an entire radical. Well, root of 45 is already an entire radical, so let's work our way up from the bottom. 4 times the root of 5, that would be the same thing as saying root of 4 times 4 times 5. And what does that give us? So 20 times 4, this would be the root of 60. 3 the root of 6. This would be the same thing as saying the root of 3 times 3 times 6. So, looks like this one gives us the root of 54. And how about 7? How are we going to convert that into an entire radical? Well, there is no radical in front of 7, but we could assume that this is the same thing as 7 times the root of 1, since the root of 1 is just going to give us 1. And this would be the same thing as saying the root of 7 times 7, by moving that value under the radical symbol, which would be the root of 49. So looking at these, we have root of 45 being the lowest. Root of 49 is the next lowest. The root of 54 would be the second highest. And the root of 60 would be the highest. So this would be the order from lowest to highest of those 4 expressions.